Hello, and welcome to our tutorial for using the ExDet tool. We're presuming you have already downloaded and extracted the ExDet zip archive from the climon.org website. There are 3 files within this archive, and the first one we need to install is the MATLAB compiler runtime. This allows the ExDet tool to run on computers that do not have MATLAB already installed. So double-click on the MCR executable file first, and you will see this self-extracting. You then need to click Next and accept the terms of this license agreement. Click Next again, and you will then be asked to approve the installation path. We suggest accepting the default. Click Next again, and then click Install to start the installation. This installation will take quite a few minutes, so we'll speed things up here to stop you falling asleep. Click Finish to complete the installation, and you'll notice that the executable file will tidy up some temporary files before closing. That concludes the MCR installation, so now we can run the ExDet tool. Double-click on the ExDet executable file and be aware that the first time you run the tool, it might be slower than normal. The ExDet tool opens with the Input window. This is where you import your data into ExDet. There are 6 buttons on this window: the Reference Data button, the Projection Data button, the 2 Reset Data buttons, the ExDet logo button that links you to our website, and the Next button. So let's run an example. In this example, we use the 2 datasets that can be downloaded along with the ExDet package from the climon.org website. These data are located in 2 folders named Reference Data Southern Australia and Projection Data South Africa. Each folder contains 4 BioClim variables in ASCII grid format. We are now going to use the ExDet tool to compare the dissimilarity of covariate space between the projection data South Africa and the reference domain Southern Australia. To perform the analysis, we first need to import the reference and projection data into ExDet by clicking on their respective buttons. Click on the Reference Data button and browse to where you saved climate datasets. Note that ExDet will read both ASCII and text format files. In this example, we use ASCII files. So highlight the reference data files that you're interested in and click Open. You will then see that these have been imported into the Reference Data window. Then click on the Projection Data button and do the same for the projection data. Browse to the location, select the files, and then click Open. You will see then these files imported into the Projection Data window. At this point in time, it is good to check the imported covariate layers in both windows. Make sure the number of layers and the order that they appear in the window is the same for the reference and the projection data. If for some reason you don't manage to get this right, we'll show you what happens. Clicking on the Reset Projection Data button clears the imported data from the projection data window. If we go back and reload our projection data, but this time we only load 3 of the covariates, you can see that we only have 3 covariates in the projection window and 4 covariates in the reference window. Clicking the Next button will bring up an error message alerting you to this problem. Clicking OK allows you to go back and fix the problem. If you get excited and click the Next button before entering the new projection data, again you will be alerted to the problem that your projection data window is empty. This time, let's fix the problems properly by reloading the 4 projection data files. If we then click the Next button, this will bring up the results window of the ExDet tool. Clicking on the Relevant button will show you all the various outputs available. On the left, we have the model interrogation outputs for the reference data. In this example, these are our data files for Southern Australia. In the middle, we have the model interrogation outputs for the projection data. In this example, these are our data files for South Africa. And finally, on the right, we have our extrapolation evaluation outputs. Let's first look at the map of our layers by selecting them from these drop-down boxes. Clicking the Enlarge button will open a bigger map in a new window. Here the shaded colour bar shows the range of the Bio5 covariate in South Africa. Clicking on the Save Map button will generate a copy of this map in PNG format. Let's close this window and explore some results. Firstly, let's look at the variance-covariance values for the reference data. This table shows the variance for each variable on the diagonal and the covariance between pairs as off-diagonal values. Clicking on the Save Table button exports the table in PDF format. Next, let's look at the correlation matrix. This opens a new window with a heat map of Pearson correlation coefficients between variables in the reference data files. You will note that both upper and lower off-diagonal values are the same. Clicking on the Save Table button exports the heat map in PNG format. Clicking on the Box Plot button opens a new window with box plots of values for each of the covariates in the reference data files. Again, these figures can be saved in PNG format by clicking on the Save Plot button. The Scatter Plot button opens a new window with scatter plots and histograms of values for each of the covariates in the reference data files. Once again, we can save this output in PNG format by clicking on the Save Plot button. Lastly, clicking on the DR button produces a map of the Mahalanobis distances for the reference dataset. The maximum value of DR is used for calculating multivariate extrapolation in projection space. By clicking these buttons, we can export the data as a map in PNG format or as GIS data in text grid format. Let's do that now. First, click on the Relevant button. Note that you don't need to provide a name for the output data file, as they have already been assigned names. Just choose or create an appropriate folder and then click on the Select Folder button. Let's look at that map output. There we go. Beautiful, isn't it? Now, let's save the same data as a GIS text file. Click on the Save Data button. We're in the right folder already, so click Select Folder, and we then generate a GIS text file. Opening that in a text editor confirms that the file is saved as a standard ASCII format, so you can use your chosen GIS package to produce a customized version of this map if you want to. Let's now go back to the results window. The outputs for the projection data are similar to those we have just gone over for the reference data. The variance-covariance table, the correlation heat map, and box plots for the projection data. A useful interrogation technique can be to generate box plots for both the reference and projection data at once, to compare differences between regions. For our example here, Bio 6 is one to focus on. Once again, the scatterplot button brings up figures of scatterplots and histograms. While we're here, why don't we save a copy of this figure? Click on the Save Plot button, and because we're still in the correct folder, we just click on the Select Folder button to save a PNG file. You can see that this has appeared as a new PNG file in our chosen directory. And once again, isn't it beautiful? Right, now back to the ExDet results window. The last button in the projection data box brings up a map of the Mahalanobis distances for the projection data. Once again, we can export this map in either PNG or text grid format. The extrapolation measures box on the right is the business end of the ExDet tool. Let's look first at the correlation heat map. The above diagonal values are correlation coefficients for the reference data, while the below diagonal values are for the projection data. For our example data, we can see that the correlation between Bio 5 and Bio 6 is minus 0.08 in South Africa, but in Southern Australia it is minus 0.49. Bio 5 and Bio 14 also have a change in correlation structure between regions. The Type 1 Novelty button produces a map of the areas in projection space with at least one covariate outside the univariate range of the reference domain. The degree of Type 1 novelty is shown in red shading, with more negative numbers implying greater novelty. Grey areas show regions within the univariate range of the reference domain. Again, we can export this in either PNG or text grid format. The most influential covariate, or MIC map, identifies which covariate is the greatest contributor to Type 1 novelty in any given part of the projection. Our legend here shows the various options. The Type 2 Novelty button produces a map of the areas in the projection space with novel combinations of covariates within the univariate range of the reference domain. The degree of Type 2 novelty is shown in blue shading, with more positive numbers implying greater novelty. Grey areas show either regions of Type 1 novelty or similar areas relative to the reference domain. We can also produce a MIC map for Type 2 novelty. Note that areas with Type 1 novelty are shown here in orange. By opening the Type 2 novelty MIC map and the Type 1 novelty map together, we can see that the orange areas on the Type 2 novelty MIC map correspond to the red areas on the Type 1 novelty map. The next two buttons combine both types of novelty into a single output. The NT1 and 2 overlaid button produces a map showing all components of the model projection. This map provides three indices on the degree of similarity or dissimilarity between the projection and reference domains. Red shading indicates regions of Type 1 novelty, with more negative values indicating less similarity. Green shading indicates similar covariate space relative to the reference domain, with values between 0 and 1. Lower values indicate greater similarity. Finally, blue shading indicates regions of Type 2 novelty, with larger values indicating less similarity. Once again, we have both options for exporting this map. The last button produces a combined MIC map for Type 1 and Type 2 novelty, identifying which covariate is the greatest contributor to novelty in any given part of the projection. Here, blue shading shows areas with no Type 1 or Type 2 novelty. So that concludes our exploration of the result window. You can use the back button to return to the input window to work on other data sets. To start again, simply use the reset buttons for both the reference and projection data windows. For further information, please visit the ExDet website, accessible by clicking on our logo. Thank you for your attention, and we hope that ExDet becomes a useful tool for your modelling toolkit. ExDet, here be dragons.